Hey guys, this is Team F. We are from Buckner High School, and I'm Felicia Caparia,
I'm Irada Zini.
And Alexis Fritchie.
and we are Trice firm. Society is currently facing a large obstacle in the world, which is coronavirus. It is essential to maintain a clean environment for everyone's safety and health. Doorknobs are a very common point where you may get in contact with bacteria. For that, we design an automatic disinfecting device with the help of UV light.
Our objective in this project was to design a handheld apparatus that would kill bacteria using UV light. We divided this project into two parts. The first part was to program a device that would activate when it detected motion. That way, every single time a person touched the surface, the device would turn on and clean the area. The second test was to test different materials that doorknobs are typically made of and determine the length of exposure necessary to kill bacteria. Our null hypothesis was that the length of exposure of the UV light would not affect growth of bacteria. The alternative was that the length of time to the exposure of UV light would affect the growth of bacteria.
The materials we used include the Arduino kit, the PIR motion sensor, Petri dishes, brass knobs, wooden knobs, aluminum knobs, dehydrated agar, alcohol, a 400 milliliter beaker, a portable electric hot plate, distilled water, sugar, a timer, a glass stirring rod, painter's tape, latex glove, chicken broth, and an incubator. And here's our method. So to program the Arduino, we use the PR motion sensor that was attached to the Arduino, and pin modes connect to the input and output. And the Arduino was programmed to turn on the LED light when the sensor was activated by motion. And preparing the Petri dishes, we had 10 grams of dehydrated agar in 200 milliliters of distilled water, 5 grams of broth, and 2 grams of sugar. And these were all mixed into a solution. And the solution was heated on a hot plate and then poured on the Petri dishes. 30 minutes was then allocated to let it stabilize. And then exposure of bacteria to the UV light. There were 10 participants that volunteered to rub their hands on randomly selected cabinet knobs, and the doorknobs were made of brass, wood, or aluminum. Doorknobs of each material were then exposed to ultraviolet light of an interval of 30, 60s, or 120 seconds. Bacteria was transferred from the knobs by immersing them in 10 milliliters of water for 30 seconds. A 5 milliliter sample of the water was then transferred to a Petri dish, and samples were incubated for 48 hours at 37 degrees Celsius.
For that, we use 3 different materials: wood, aluminum, and brass knobs for exposure of bacteria to UV lights. Among that, wooden knobs are way more safety for the people to use, but there were no clear distinction could made between the length of exposure to the UV light and the density of the bacteria.
In conclusion, COVID-19 has reinforced the need for increased public sanitation and cleanliness. That way, the virus that easily spreads has shifted the way that viruses easily spread has shifted the way the public regards infectious diseases and general germ transmission. We failed to reject our null hypothesis that the UV light would not have a significant effect on bacterial growth on wood, brass, and aluminum surfaces. However, we were able to successfully program an Arduino to automatically activate when detecting motion and activate an LED light. Future iterations of this will replace the LED with a UV light as a means of automatic disinfection. While we were not able to confidently determine how long a door handle should be exposed to a UV light, we were able to verify that doorknobs are an important point of transmission and they should be regarded as a potential point of infection. More studies need to be done on the effectiveness of UV light and its antimicrobial abilities. COVID cases and deaths are dwindling, but infectious diseases are not going away. Further research of this topic could build towards public health initiative to keep shared spaces more sanitary and to prevent the spread of the next novel infectious disease.
Trice Firm would like to thank our teacher, Ms. DeYoung, our student mentor, Leah Sandoval, and our professor mentor, Rodrigo Bernal Montaya. We'd also like to thank all of the UTD Youngwise staff and sponsors, including Capital One, State Farm, Texas Instruments, Dallas ISD, and Richardson ISD. Without their help and support, this project would have never been possible.
Thank you.
Thank you.